Oscillations. The purpose of this lab was to compare the predicted computational model with the observed model of a spring and tracker. The preview of the main result was there was a similar change in position over time, especially in the x direction, and the change in total energy is 0. This was based on Newton's second law, which states that the net force equals change in momentum over change in time, and which led to the velocity update formula and position update formula. So the energy principle states that the total energy of the system equals work done on the system by the surroundings and the exchange of thermal energy. The system should be defined, and there's a possibility for multiple different types of energy with multiple objects in the system, including these types. This is the free body diagram with the spring force going upwards and the gravitational going downwards, and the net force equals 0. It's also in static equilibrium, so it's at rest at this point. And this is the total energy of the system and how it was calculated. Since the system is earth, spring, and mass, and there's nothing in the surroundings, the work done by the surroundings equals 0, and the thermal energy equals 0, so therefore the total energy of the system equals 0. There were multiple objects in the system, including potential energy of the earth and the potential from the spring. This was the tracker analysis video where the position versus time was calculated in the x and the y direction. So these were the results of the tracker analysis in the x and y position versus time, with start time, initial position, initial velocity, and total time. These are the initial conditions put into the computational model with the velocity and position and the mass. These are the constants in the computational model, and the spring constant was calculated with the equation T equals 2 pi root m over k, which equaled 5.05 newtons per meter, and the relaxed length of strength was calculated with the net force formula, which equals 0.08012 meters. The equations to code, these are the equations to code for the energies involved and the distance from a relaxed length of spring. These are the equations to code for the net force, velocity update, and position update formulas. These were the iterations in the computational model with the delta total energy of the system. And then this part of the code was comparing the video analysis measurements to the computational model. So these were the results of the computational model comparing both. The total energy of the system equals 0, which is this orange line, and then the x position, as you can see, lined up more with the model versus experiment, while the y position had a little more of a difference. So the x position versus time of computational model was very accurate, while the y position had a less accurate time at predicting the y position relative to the x position. Change in energy versus time comparison was the change in gravitational and spring potential are opposite in sign and oscillate. The change in kinetic energy oscillates with less magnitude. Possible sources of error included it didn't account for other potential energies in the system, including thermal, electric, and rotational. It's not consistent with the center of mass and tracker experimental analysis, and it did not account for other forces, including drag. So what does it mean? Is the energy principle satisfied? Yes, it is satisfied since the delta energy was equal to 0, as seen here with this orange line. According to the energy principle, total energy should equal 0. Since the spring potential is opposite in sign to gravitational potential, the kinetic has the same sign as potential energy with less magnitude. The overall sum is 0. So this is based on the tracker analysis of the y position and x position. The time period between two crests or troughs is basically the period. So the average oscillation period was found for the x and y position. So here's the x position and here's the y position, and the difference between those two is equal to 0.10267 seconds. So this difference in oscillation affects the calculation of the spring constant, the spring force, and spring potential energy. The difference in oscillation periods is caused by the drag force, incorrect tracking with center of mass, and the camera distortion for the tracker analysis. Thank you.